Hello everyone, welcome to my second video of union find. In the first video, we constructed union find in a naive manner using while loop to perform find. In this video, we are going to make union find a data structure. In case you were wondering why we should build union find as a data structure instead of repeating the similar codes again and again whenever we need them, well, part of the answer is already in the question. When we build it as a data structure in a class in advance, we can call union and find whenever we need it. We leave functions to functions and objects to objects. The people outside functions and objects do not need to worry about the ways they work. It also helps to make our codes clean and easier to understand. When it is easier to understand, it will be easier for people to debug and maintain. Let's look at the pseudocode I came up with for union find class. If you are new to union find, you can build with your favorite language. Since the data structure we store our parent nodes is an array, we need to put the array in our private attributes, so people outside the class cannot modify the array directly. Moreover, we need to initialize the array in our constructor. We set the size to a number and initialize the value to -1. We build find and union in the public field. In our union function, the two parameters are the index number of the nodes we need to perform union. We call find with the two numbers. If their root nodes are the same, which means they are in the same set, we can therefore say we detected a circle in the graph. If not, we should union them together by modifying the value of one node to the index of the other node. In our find function, instead of using while loop in the last video, we can find in a recursive manner. If the current node is not a root node, we find its parent node. If it is a root node, we return the node. So far, we have discussed a naive approach of constructing union find data structure. It is naive for reasons. Let's look at an example in which a very simple modification can save our naivety. In our union function, it is always the case that one certain node points to the other node. If we construct our array with inputs in its extreme example, whenever I call find on node 0, we need to go all the way up to the root node. If there are n nodes in the path, we'll get a complexity of On. Then you may come up with, why don't we do something in the process of the find function? Why don't we just change the parents of nodes in the path to the final root node? Actually, we can do it by making a very small change to our find function. We just modify the value of the nodes in the path to the result of the final root node, and then return its value. Our graph will become this. It is much flatter than the previous one. And this small improvement is called path compression. Another part of the naivety is that the node we are asked to build union find, in most cases, are not numbers from 0 to n-1. They can be names, IDs, or non-string of anything. The way to deal with the problem is simple. We just build a hash map and map every name we encountered to a node index, starting from 0 to n-1. Then we can still perform union find by finding node index with the hash map. Congratulations on following up to the end of this video. If you understand everything so far, you have made a great progress on union find. In the next video, I'm going to talk about union by rank. Thank you. See you in the next one.